this is just a way that we can use pieces of the equation to help us understand about the graph and about the types of answers that we're going to look at. So the first thing I want you to do is copy the chart. Actually, you have the chart, but let me talk about it for just a second. So notice here that they use the word cuts. I would say intersects, touches. So if it does not touch the x-axis, that means my answers, I have two imaginary answers. We could also say there are 0 real answers. If it just touches once, the amount of times that the graph touches the x-axis tells us how many real answers. That's why there's 0 real here, 1 real here, and 2 real here. And so we can find that by the type of answers, and we can determine the type of answers by the discriminant. The discriminant is actually in the formula booklet, so that's a good thing, but you got to know what it actually stands for. Okay, so if the discriminant is positive, it just means that it's going to touch twice. If the discriminant equals 0, it's only going to touch once. And if the discriminant is negative, it will not touch at all. Okay, so I would say this next section is pretty, I really don't talk about it a whole lot. The way I would think of it, what I actually wrote down is positive definite just means that the y value will always be, it's definitely positive if the leading coefficient is 0 or greater than 0 positive, and the discriminant is negative. Both of these are where the discriminant is negative, so it doesn't touch at all. So if your leading coefficient is positive, everything's going to be positive. If the leading coefficient is negative, it's always going to be negative. That's really all it's telling you. Okay, so use the discriminant to determine the relationships. So we always start with the discriminant equals b squared minus 4ac. Remember, a, b, c when it's in order. So a is 1, b is 3, c is 4. So by discriminant, b squared, 3 squared is 9, minus 4ac. That's 16. 9 minus 16 is negative 7. So does not touch because it's negative. To me, this will make so much more sense. I wish we would do the quadratic formula first. La 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 la. Just wait. Because this really ties directly to the formula, but IB does it in a little different order. Okay. We always just start by writing out the formula, and then we plug in our values. B is 5, so b squared is 25. 4, a is negative 2, and c is 1. Now, I'm going to subtract a negative. Anytime you see 2 negatives, that'll just make that a positive. And then I just add together. Because this is greater than 0, it will touch twice. And that's just telling me there's going to be 2 real answers. Okay, so this one can be a little confusing at first. We almost work our way backwards. So let's first find the discriminant. So b squared minus 4ac So in this case, we're going to use this for A, B, and C. B squared, negative 6 squared is 36, minus 4, A is 1, and C is K. Anytime there is a variable in an equation, you just continue, you put everything in the same spot and just go with it. So what do we know if a graph cuts the x-axis twice? That means your discriminant has to be greater than 0. Well, in this case, what's the discriminant? This is for A. 36 minus, I'm going to just simplify to 4K. What would make this greater than 0? Well, I'm going to add 4K. Divide by 4. I just solve for K. Be really careful here. This is telling us K is less than 9. You might want to rewrite this, because usually with inequalities, we want to have the variable first. Okay, if it touches it once, that means the discriminant equals 0. We're just using the same discriminant for the whole thing. 36 minus 4K equals 0. Oh, goodness. So in this case, K equals 9. So you set up everything the exact same way, you're just solving it a little bit different. And if it misses it, it does not touch at all. That means our discriminant is less than 0. So we solve for K this way. If you always think of it as from the perspective of the variable with inequalities, K is greater than 9, or just switch places. So that means you got to flip the inequality. And that's the end of C. I'm going to go ahead and do D at the same time. They're both kind of shorter, and so we're just going to combine them into the same day. Okay, notice in this one, it cuts the x-axis twice. There are 2 x-intercepts. If we know our x-intercepts, then I know my intercept form. So I'm going to do my y equals. Here's the part we don't know the dilation of it. So I'm just going to insert my intercepts. X minus -1 is x plus 1, x minus 3. So then we can use this point, 0, 3, and this is my x coordinate when this is my y coordinate for this particular equation. So I can substitute 3 in for y. I can substitute 0 in for x. 0 plus 1 is 1. 0 minus 3 is -3. And it leaves me with an equation that has one variable, and we can determine what that coefficient is. So a times 1 times -3 is -3a. So I can see my a coefficient is -1. And this makes sense because my parabola is going upside down, so my leading coefficient should be negative. So I just plug in my -1 to get a final answer of -1 with my intercept form of x plus 1, x minus 3. Then for letter B, notice if it just touches it once. I always say if it bounces off the x-axis, it's almost like it's both in intercept form and vertex form, because the vertex is at 2, 0. So we can say, but I still don't know my leading coefficient here. So So I can take x minus my x coordinate squared plus 0 technically, but we really don't need that 0, so we usually leave it off. And then you can see how it can be intercept form, because I could just write 2 of them at the same time. So anytime it bounces off the x-axis, it's always quantity squared here. Okay, now I'm going to choose another point on my graph. So the only other point we know is 0, 8, my y-intercept. So I'm going to substitute 8 in for y and 0 in for x. And I get 4a. So when I solve for a, I get 2. So my final answer, if I come back up here, is y equals 2 x minus 2 squared. Okay, so in this one we have to be a little more creative. They give us one x-intercept, but not the other. What we do know, though, is this x-intercept is how far away from the axis of symmetry. So if this is at -2, if I go back to -1, 0, 1, this is 1, 2, 3 away from the axis. 1, 2, 3. The other x-intercept has to be the same distance. So if I go 3 away from 1, that puts this point at 4. So we now have 2 x-intercepts of -2 and 4. But I don't know my leading coefficient. So x minus -2 times x minus 4. Then we can use this other point on the graph of 16, 0, substituting 0 in for y. And, oh, I did that backwards, sorry. All of a sudden I'm like, that's not right. The y is 16, the x is 0. Okay, so 16 equals 0 plus 2 is 2. 0 minus 4, -4. So now I multiply my right side, I get -8a divided by -8. And a is -2. So then I can come back up here and rewrite my equation with everything included. Okay, so this wants us to find the equation whose graph cuts the x-axis at 4 and -3. So that gives us 2 intercepts. So I'm just going to plug that part in right away. It also gives us a specific point of 2, -20. So I can substitute -20 in for y, 2 in for each x. Two times -4 is -2. 2 plus 3 is 5. Multiplying my right side gives me -10a. Divide by -10. I get a is 2. So I can now substitute my a back in. And we're left with intercept form. But if the last line they ask us to change this into standard form, you can do this one of 2 ways. I'm going to distribute my parentheses first. So I'm going to hold off and keep the 2 on the outside. So distribute x, distribute -4. I can combine my like terms. That's -x. And then I'm going to distribute my 2 to get 2x squared. I'm really going to do that times my negative x because I combine my like terms. So sometimes you can get to an answer, but unless you finish it the way they ask, you won't get full credit. So every time you get done with a problem, go back and read it to make sure that you have answered the question.